Hi everyone, myself Dr. R. Satya, Assistant Professor in the Department of Information Technology in Kungnadu College of Engineering and Technology. In this session, we are going to see about data structure subject. Okay, this is one of the important subject. If you want to do any programming, you need to know the concept of the data structure. Okay, so first see about what is the data structure, and next what is structure, and finally what is mean data structure. Okay, so, what is data? A value or set of values of different data types such as integer, float, character, etc. It is called as data. Okay. Next, what is structure? Way of organizing and storing information so that it is easy to use. It is called as structure. Okay. So, what is data structure? Way of organizing and storing the data on a computer so that it can be used easily and effectively. It is called as data structure. Okay, so what is exact definition means? It is a way of organizing, storing and retrieving data and their relationships with each other. Okay, so this is the representation for data structures. First one is stack representation. So here top value is incremented and decremented. Whenever we are going to insert one element means top value is changed. Okay, so next one is queue representation. Here front and rear value is performed. So we are going to insert one element means the rear value is incremented by 1, and then we are going to delete one element means front value is decremented by 1. Okay, so the next image represents tree structure. Here root node, child node, that means parent node, child node, siblings, and leaf node. This is the representation for tree. Okay, these are all the data structure representations. Okay, so next, different types of data structures. That means classification of data structures. So uh, different types of data structures are primitive data structure and non-primitive data structures. Okay, let's see the examples for the primitive and non-primitive data structures. Okay, so primitive data structures are nothing but integer, character, float, boolean. Okay, so next, non-primitive data structures nothing but linear and non-linear data structure. Okay, so here let's see the example for the linear and non-linear data structures. Linear data structure is nothing but array, linked list, stack, queue. Okay, these are all the linear data structures. And next, tree and graph. This is the non-linear data structures. Okay, these are all the different types of data structures. Okay, so next say about abstract data type. Okay, so what is abstract data type? It is a type for objects whose behavior is defined by set of values and set of operations from user point of view. Okay, it is called as abstract data type. Mentions only what operations are to be performed but not how they will be implemented. Okay, abstract data type is the specification of a data type within some language that is independent of implementations, that is called as abstract data type. Okay, so next some examples for abstract data types are available. So what are the examples? List abstract data type, stack, queue, etc. Okay, so some operations on this abstract data types are insert, delete, find. These are all the list abstract data type operations. And next, push, pop, is full, is empty. These are all the stack abstract data type operations. So next, enqueue, dequeue, is full, is empty. These are all the queue abstract data type operations. Okay, so next, what is list ADT? List ADT can be represented into two ways. Okay, so first one is array ADT and next one is linked list ADT. Okay, so array ADT represents this is the array index value. So this is the array element values. Okay, so next, list ADT, it has two fields. One is the element field and another one is the pointer field. So this is the representation for linked list ADT. Okay, so next, array ADT collections of elements of same data type. Okay, what is the syntax for array-dt? First, to initialize data type, what is the data type name, and next array name, next you mention array size. Okay, so this, one example, int a 50. Okay, int is the integer data type, and next a is the array name, next 50 is the array size. So this is the syntax for array-dt. Next, what are the operations of performed in array-dt? Insertion, deletion, search. This is the common operations. Okay, so whenever we are going to insert one element means here insertion operations is performed. Likewise, deletion and search operations. Okay, so this is the representations for array-dt. The syntax for array-dt: integer array 6. Okay, so ARR is the name, array name, integer is the data type, 6 is the array size. So array size is 0 up to 5, 0, 1, 2, 3, 4, 5. This is the representation for array-dt. Okay, so some issues are there in array-dt. So first issue is fixed size. Okay, resizing is expensive. Okay, so next one is requires continuous memory for allocation. Difficult when array size is larger. Okay. Next, insertions and deletions are inefficient. Elements are usually shifted. Okay. So wastage of memory spaces unless the array is full. These are all the issues in array-dt. Next one is linked list ADT. So linked list is a linear data structure. Array-ADT is also linear data structure. Okay, made up of a chain of nodes. Here consecutive nodes are there. Okay, each node contains two field, namely data field, and another one is a pointer field. Okay, so last node of the list is pointed to null value. Okay, this is the example for linked list ADT. Okay, so next, see about representations of node in linked list. Okay, each node, I already told you, each node contains two fields. One is the data field, another one is the pointer field. Data field means contains data element to be stored. Okay, this is the representations for node. Okay, this is the data field, and green color represents the address of next node. Okay, this is the declarations for node. Okay, so you create a node means you mention struct node, open brace. What is the two field? One is the data field, another one is the pointer field. So first mention data type, integer data type, data, struct node, star data, open brace. Okay, this is the representations of node in linked list and declarations of node. Okay, so next is see about creating a node. Okay, so first, create a node means this is the syntax for creating a node. Okay, n is equal to struct node star mal allocation of size of struct node. Okay, so n arrow operator next equal to null. Okay, so this is the representation for creating a node. Declaration for new node means struct node, open brace, int data, struct node, star data, close brace. Okay, so next is see about types of linked list ADT. Okay, there are two types are available. One is singly linked list, doubly linked list, circular linked list. Okay, thank you.